Alright, so today we're starting day 2 of lesson 3.1. Sorry, 2.3. I don't know where my mind is. We are going to be using reference angles to find exact values today. So, first thing would probably be helpful to know what a reference angle even is. A reference angle is the acute angle formed with the terminal side of the angle and the nearest x-axis. So what that really means is that let's say we have this angle I've drawn here below. This angle measure, we'll call it theta. Clearly is not acute because it wouldn't fit in a right triangle. So what we're going to do today is we're going to talk about how we can also find the reference angle, which is the angle measure drawn from the terminal side here to the nearest x-axis, which would be here, and how these two angle measures are going to give us the same numerical value if we were to plug them in a sine function. Meaning, if I took the sine of my red theta here and say I got 1/2 as an answer, if I plugged in green theta here, or theta prime, because it has the apostrophe there, if I plug that into the sine, it would also equal 1/2. It would give me the same thing because they have the same terminal side. And we've been using the terminal side to find our x, y, and r values, so they're going to have the same value. Here is what your book says about finding reference angles. A couple key things here. Here is how you would find a reference angle in each quadrant. Here's an equation. Some of you guys, I'm sure, would rather draw the picture every time. Some of you guys are more equation oriented. So either way works. I personally like the picture so I can see where I'm putting it. But if you don't want to draw the picture every time, if you know these for each quadrant, then you're in good shape. So why a reference angle is important? Well, as I was saying before, what it allows you to do is it allows you to find an exact value for an angle measure that normally wouldn't fit into a right triangle. And so it also allows you to find, if you're not given the terminal side information, we could use, in this case, our special case right triangles, which we use a lot in this class. We can use them to find our numerical values, our trig function values. So let's look at the sine of 240 degrees. If I were to draw that out, it's going to look like this. With that is our angle. Now, this is 240. This is 180. That means that the difference between the two, or this distance here, which would be our reference angle, would be 60. And some of you guys are probably seeing the connection. Other of you are probably like, what in the heck is he babbling about? So we know this angle here is 60 degrees. So if this is 60, what I can do is I can use my special case triangle, and I know what the other side lengths are going to be. I know that opposite of the 60 should be root 3. I know that opposite 30 is 1, and the hypotenuse, or r, equals 2. So now I have all these different values, and I can use those to find my solutions, or to find the solution to this problem. One thing to keep in mind here, though, and why I like drawing the picture, since this is in quadrant 3, all the numbers on this axis are negative. All the numbers on this axis are negative. So that means my root 3 and my 1 have to be negative values. So if I'm going to now find the sine is going to be y, which is negative root 3, over r, which is 2. Well, that's all I have to do. So take a second. Here's just some basic steps to kind of follow along for what we did on that previous example. Like I said, I would pause the video and then write these down and resume. Alright, let's try some of these examples. So let's just look at, we'll do one together. It's been pretty customary. And then I'll have you try the other 3 on your own. And we'll go over them in class. So 390 puts me there for this first example. That's 390. Now some of you are saying, well, this is 0. So how in the world am I getting an acute measure between 390 and 0? Don't forget, it's also 360. So we're going to ignore the 0 for a second. what's the difference between 390 and 360? Hopefully we get 30. Otherwise, I am a terrible math person. Oops, that didn't look good. Let's redo that. So that's 30. Okay, here's our triangle. So that's 1. That's root 3. And that's 2. So then if I'm finding the tangent, tangent's y over x. So it's going to be 1 over root 3, which I would then rationalize to come up with root 3 over 3. That's it. We can also check our answer. This is quadrant 1. Everything in quadrant 1 is positive, so it should be a positive value as an answer, which we got. So that concludes the video for today. Like I said, try these other examples on your own, and then we'll go through them in class tomorrow.